Eliminate the parameter and use the rectangular equation to sketch the plane curve. So here we have these parametric equations. We have x equals t minus 2 and y equals t squared. Now it does say to eliminate the parameter, right? So we'll look at that in a little bit. Now one thing we can do is we can always just plot points to graph this, right? So and what we mean by that is we'll get our x and our y, right? But remember these are parametric equations, so now we're going to have this other variable t, right? And we're going to use t to generate the ordered pairs x and y. Notice that there's no restrictions for t here, right? It doesn't say, oh, t has to be positive or t has to be a number less than 7 or something like that, right? Okay, so actually here we can pick any values of t that we want. Okay, we really, don't want to go too small or too big, right? So let's pick t equals -3, for example, right? When t is -3, right? X is going to be -3 minus 2, which is -5. Y is going to be -3 squared, which is 9, right? So we have actually generated one ordered pair. We can keep doing this, right? I don't know. Let's pick a couple more, right? So -1. When t is -1, x is -3. Y is going to be -1 squared, which is 1. And we can keep going along here, right? But we notice, yeah, we can do this, but it may take a while, right? Yeah, who knows what graph we'll get. Okay, so eliminating parameters sometimes is a better option. Okay, so when it says eliminate the parameter, it means we're going to eliminate t. Okay, because we're used to equations in x and y. Okay, so we're going to eliminate t. So how do we do that? Well, in this case, right, this is not a trig equation. We don't see like any other type of weird functions, right? So the first thing we should do is pick one of the variables, either x or y, and solve for t. Okay, now this has a square in it, so we probably want to leave that alone. So let's take a look at this guy, right? I'm going to take the x equals t minus 2. I'm going to solve this for t. This one's only one step, but I'm just going to add 2 to both sides. So x plus 2 is equal to t. So I picked one of these equations, I solved for t, and now I'm going to just plug that into the other equation, right? So y equals t squared, but in the place of the t, I'm just going to replace it with the other equation that I just found, right? X plus 2 squared. And notice that this equation does not have a t in it, right? This equation is only in terms of x and y. Hey, wait a minute. Yeah, that's a graph that I should know, right? This is a quadratic or a second degree polynomial. Okay? And we know that quadratics always have a U shape. Okay? But in this case, it's a U that is shifted to the left 2 units, right? So we're going to go to the left 2 units. And you notice, well, we can actually use these points to, well, a couple of these points to help, right? So our graph is just going to be a U that goes a little something like this, okay? All right. So, yeah, maybe we could have pulled out at like 8, 10, 12 points and got the same graph, right? But sometimes eliminating a parameter is also good. Okay, now we actually do want to denote the orientation of this curve, right? So I really shouldn't do the arrows like that, okay? But when we say the orientation of the curve, what do we mean? We mean, right, increasing values of t, right? So of course, t is negative infinity, right? We can start negative infinity, but if you realize that's going to be all the way up here, right? But right, my points actually keep going this way, right, from left to right. Okay? So here's t equals -3, which was this point right here, right? This point right here was t equals -1, t equals 0. So we notice that as we're moving this way, right, that's the orientation of the curve, right? So we're going to draw arrows to denote that going this way.